Two identical, uniform, thin planks, each of mass 40 kilograms, are propped up against one another in equilibrium on a rough surface as shown. Each plank is at an angle of 30 degrees to the vertical. What is the magnitude of the friction force at point P? So there's a nice bit of symmetry that we're working with here. So if we had each of them with their weight at the center, so that's 40g, and this one is also 40g. And then because they'll naturally fall outwards, then we'd expect friction to go inwards. We'd also expect a reaction force to balance their weights. So this would be R. And then this would also be R. And then what would have balanced friction? It would just be the contact between them here. So the right pole would exert force here. And then the left pole or plank will exert force this way. So if we wanted to find out the friction, clearly this is a moments question, and the best choice of pivot would be at this point. And that's because this would not involve finding out these forces between the two planks at the top. So if we considered moments here, let's look at the perpendicular distance of everything. So if we consider the plank to be of length 1, for example, or L, notice they haven't given us a length here because all of the lengths should technically cancel out. So because this is a matter of ratios or proportions, all that matters is what ratio that each of the forces are to each other when it comes to moments in this case. So if we wanted to work out 40g, which is 400, this would be providing an anti-clockwise force, and the distance this would be at is L over 2, and it would be sine 30. So that would be 400 times sine 30. Well, times a half times sine 30 times L. Now, the other force R would also be equal to 400, but this would be clockwise. So this would be 400, and then it would act at a distance L, but sine 30 in this case. So it'd be times sine 30 degrees times L. And the last force would be friction, which is also acting anti-clockwise, again considering just the left-hand side. So this would be F times, well, what distance is it acting at? This would be L cosine 30. So this would be cosine 30 degrees, and again times L. And this would be the anti-clockwise moment, and then the 400 times sine 30 times L would be the clockwise moment. Notice in all of these, L will cancel out. So that's why whether you called it 1 or another number, it didn't matter, and that's why they didn't need to provide it. So now all we need to do is just work out what we've got here. So we've got 400 times sine 30, that's equal to 200. And then we have 400 times a half times sine 30, so that's 200 over 2, so that's 100. And then we've got plus f times cos 30, so that's plus root 3 f over 2. So rearranging this, we've got 200 take away 100 is 100, and then times 2 over root 3. So f equals 200 over the square root of 3. Sorry, it's meant to be a 3. And then that answer should be B. So this is a magnitude of the friction force at P. Hopefully the logic was all clear there, but if you have any questions, please do let me know.